To load our game, you load the snake top module on Vivado. You can start the game by pressing the up, down, or right arrow key. And then if you press the left arrow key, you would run into yourself and die. After you click any arrow key, you're able to start the game. You gain a score by every time you eat an apple, which will increase your length, the size of the snake, and the score, which is seen on the FPGA display. The length is seen on the VGA display. This is done dynamically, so it's done at the same time. If you hit a border, or if you self-collide, given that you eat yourself or something, you reach the end game state, which will set the score back to 0. To restart your game, you must press reset. However, if you hit reset before you reach the end game state, the snake will move back to its original position. But you get to keep your score. So this is like an alternative pause button we have developed in the game.
The maximum score you can achieve on our game is a score of 69. Given that our FPGA is programmed to a limit of 69. That's the highest score that can be displayed on the FPGA. However, the maximum score until the snake stops increasing in size is 18. Like after you eat apple 18, the snake will stop increasing. But you can keep playing until you get a score of 69.
We have different difficulty levels, which we have a difficulty switch for. The switch turns the game or toggles between the slow mode, which is the caterpillar snake, which is seen on the display, or the much faster snake, which is a red, yellow, and black snake. They both have their own color palettes associated with them, and you can switch back and forth while you still are playing. So it's just a live mode. We have a couple of bugs throughout our game. For example, if you hit the reset button while in the first palette or palette equals 0, the offset is messed up, given that the border increases or the display moves to the left and up. If you switch back to palette when it equals 1 and you hit the reset, this will correct the issue, as seen on the display. So due to several if statements and priority levels on the VGA display, the reset button saves the length of the snake, and the endgame doesn't stop it. In order to start fresh, you must crash into the border or yourself, which will then reset your score, which is a standard operating process.
Because the endgame state keeps you in the direction you last pressed, if you died while moving to the left, you will restart the game, always eating the tail until you either click the reset button to stop or any other direction to keep playing. This is due to the issues we had with the reset state and the endgame screen, but we will make sure to include this detail in our game instructions.
Apples can sometimes be generated inside the snake's body, so like overlap. We aren't sure if it's just the tail or the head or the first 2 blocks, as it happened way too infrequently for us to test. The apple is based on a timer. The clock places the apple anywhere on the screen based on the apple gen, or the apple logic we created. So this can happen randomly, and obviously as the snake gets bigger, this is a more frequent error. However, it happens very minimum amount of times.
I'm going to start us off with the code. Here's our snake module, which is our topmost module that instantiates and connects every other module in our project. Here, we are able to provide inputs through the FPGA and receive outputs that work together to create the game, with every module having relevant inputs, outputs, and/or wires or registers that help connect the modules together. We currently have a clock divider, a module for FPGA button inputs, a module VGA display that generates our snake and its logic, another VGA display that checks for display activity, and a top module for the FPGA display LCD. These will be explained later in the video. Starting us off with the VGA display module, this module is one of the largest parts of this project, and it instantiates 3 modules itself: the snake's clock, the apple generation logic, and the end game conditions. We then use their outputs to set the snake's initial position in the VGA, as well as the movement directions and the proper displays within the VGA. We then have a case condition in which we move right, down, left, or right, or if we are not pressing anything, we move in the direction of the previous input. Here we have a series of if statements that help us set the proper coloring for every object in the game. The integration of a color palette switch is a feature that effectively changes between a snake when palette equals 0 and a caterpillar when palette equals 1. Essentially, VGA display is responsible for the user interface that makes the game look the way we want it to. This here is the clock that controls the snake movements. And if we look down here, there's an if statement that looks for the same switch we use for palette, allowing us to introduce two different game modes in which caterpillar has a slower clock than snake, making palette a bit more than just aesthetics. This module basically generates random apples around the screen. The randomizer is based on a counter between 0 and 4000, along with some modulations to set a new apple position. We have successfully implemented this feature, but like we mentioned earlier, there is still a chance that an apple generates inside the snake's body. Nevertheless, the apple does generate in random positions besides the initial state. Given more time, we would have liked to make the body an input of this module and implemented a condition that prevents an apple from generating on the body, similar to what we did for the snake's head. This endgame module states the conditions that will output a game over state, in this case endgame. For this, we have defined our game borders and established an if statement that can detect anytime the snake's head collides with a border. We have also defined the snake's body in this module, making the length of the snake dependent on the score with our maximum length being 20, including the two initial tails. This happens when the score is 18 or higher, as the other conditions are related to the current stored memory. Finally, we have an if statement that provides the game over state if there is either a body or border collision. This is then sent back to the VGA display module to reset the score, the snake's position, and other parameters. Due to time constraints, we were not able to make the reset button where it exclusively exits the endgame screen, so our game currently resets on the clock provided by the VGA display, in this case, the snake's clock. One of our current bugs, as we mentioned in the demo, is that due to the if statement's priority levels in the VGA display module, there are currently issues with the reset button in which it saves the length of the snake when pressed. There's also an issue with the endgame since it does not stop the snake from moving once you meet an endgame condition. In order to start fresh, you must cause a collision between a border or your tail, which resets the score and the snake size. If you want to stop moving, you must then click the reset button. This is most likely due to the error clock as we input and output information from our modules, but it could also be the fact that we default to the last press output when we die.
In our module button inputs, we control the FPGA inputs, and we use debouncers to clean up the signal so the information won't get clustered in the button, and we can take one input at the time. We have C up, C down, C left, and C right as wires, and we pass them each through a debouncer, basically the same debouncer as Lab 3. We just tailored it to our needs. And we also have a 3-bit output called direction, and depending on the value of this variable, we direct the snake. The direction up and down did get flipped, but we just switched it in our constraints file. Module VGA display 2, we're basically refreshing the VGA. We are responsible for the H-sync and V-sync outputs of the VGA, and we are making sure that everything is being displayed in the correct area as we play it. We also encountered a different bug where the H-sync and V-sync are messed up on the right side, and it offsets about 10 to 5 pixels respectively. To correct this bug, it's simple. You just need to switch back to the caterpillar mode and hit reset, and it corrects the issue.
Moving on to the top module, this entire module controls our score output on the FPGA board. As can be seen in counter control, each digit is composed of 7 segments that correspond to 7 letters, A through G. We turn these letters or segments on or off, depending on what number we want to generate. And this controls the score output that we can go all the way up to 69 with. We've also used an encoder to take our score count and display it on the FPGA board. In terms of things we would do if we had more time to make our game better, we'd want to ensure that our reset button resets the snake's tail in the score of the game. While we were able to make this happen a little bit closer to the end, we're not sure if it's a tried and true implementation. We'd also like to adjust the clock issue with the endgame and make sure our endgame lasts longer so we can reset it properly. It'd be great to be able to fix the bug with the offset created when palette equals 0 and you click reset. And implementing the keyboard for ease of access would be a great feature we'd want to include too.